All right, multiplying rational expressions, and then we're also going to divide rational expressions. So the way we multiply fractions is we go straight across, numerators times numerators, denominators times denominators. So what I like to do is anytime I see a binomial or trinomial of some sorts, I like to put it into parentheses. That says this has to stay together, and I cannot split up that 12 and that 18. So I like writing one big fraction. That's going to be multiplied by 14. That's your entire numerator. Your denominator is 7 times the 3 minus 2x. So we have 12x minus 18 over 7 times 14 over 3 minus 2x. I can write all the numerators together, as long as I use those parentheses, and all the denominators together. So what we're going to do, because these are binomials, we want to look to factor. We can factor out this binomial in our numerator, the 12x minus 18. We could take out a 6. And if we factor 6 out, we're left with 2x minus 3. We still have the 14, we still have the 7, and the 3 minus 2x in the denominator, we actually can't simplify. There's nothing that comes out of there. So you can divide or cancel identical terms in the numerator and denominator. We divide pieces that are the same. So there's a 14 in our numerator and a 7 in our denominator, which means we are able to divide both of these numbers by 7. 7 divided by 7 is 1. So I'm going to cross that out, and I'm going to put a 1 here. 14 divided by 7 is 2, so I'm going to cross that out. So I'm doing the division right now. So now I have in the numerator 6 times 2. So I have 12 times 2x minus 3. And in my denominator I have 1 times 3 minus 2x. Now here's a special case. What we have in the parentheses are not exactly the same. So technically, if they're not the same, we shouldn't be able to cancel them. However, these are opposites. 2x minus 3 and 3 minus 2x. Write a rule up here. A minus b and b minus a. When you have identical terms that are flipped in a subtraction problem, the only difference is that they're a factor of -1. So if you multiply -1 by one of these, it's going to give you the other expression. So essentially, if we solve this expression, whenever we are dividing these types of expressions, it's always going to cancel or divide and give you -1, not +1. So we can simplify this. We can divide it, but we are going to be left with -1, not +1. So the answer is going to be -12. We get -12 over 1. So now we'll do a problem for dividing rational expressions. Concept's going to be the same. The only difference is we're dividing fractions. So when you divide fractions, you keep the first fraction the same. We are going to change that multiplication or that division sign to multiplication, and then we're going to flip the second fraction. So our original problem, x squared minus 4x minus 21 divided by 2x squared minus 98, and that's divided by x squared plus 10x plus 21 over x squared plus 14x plus 49. So the second fraction is going to flip, and now we have multiplying fractions. So all of this we can write as one large fraction. The first numerator times the second numerator in parentheses, first denominator times the second denominator in parentheses. And now we have to factor, which is where the fun happens. So if you don't remember how to factor these, you're going to have to find another video that I have or someone else to remind yourself. But this first numerator is going to factor into x minus 7 times x plus 3. The second numerator is going to be x plus 7 times x plus 7. I don't want to write it squared because I want to be able to see all my pieces. The first denominator, you take out 2 as a common factor, and you're left with x squared minus 49. So this is a difference of squares. This has to be factored one more time. So that's going to break down to x plus 7 times x minus 7. And then we have our 2 in the front. So I'm just going to cross out this original one that we had and replace it with that. Our second denominator factors into x plus 7 times x plus 3. So here we go. We're factored all our pieces. That's the whole concept of the multiplying and dividing rational expressions. So we can divide anything in the numerator and denominator that are the same. I see an x plus 3 in the numerator and denominator. So I'm going to circle them and divide them out. That's going to give me 1. I see an x minus 7 in the numerator and an x minus 7 in the denominator. Again, I circle those, cross those out. That's 2. I have x plus 7 in the numerator and x plus 7 in the denominator. Cross those out. And another x plus 7 in the numerator and another one in the denominator. So almost everything cancels except for that 2. So that 2, and this is where some students get a little confused, that 2 is in the denominator of your fraction. So when you write your answer, that 2 has to stay in the denominator of your fraction. Everything's gone in the numerator, but the identity property, we can always multiply anything we have by 1. So 1 would be in the numerator, 2 is in the denominator, and your answer would be 1/2.